In this video, we are going to discuss about the stress distribution of the neck. Okay, so if you see in our analysis, say the specimen, the necking begins and it's continuing, and while it's continuing, it will be something like this. Okay, it's a local phenomenon, and it's happening locally at one particular region. Okay, now what we do is in order to calculate the true stress true strain curve, what we are doing is we assume something. The assumption is in this cross section area the stress distribution is uniform. That's an assumption. Okay, with that assumption we are calculating the true stress. The question is that assumption reasonable? Okay, now if you see from your strength of materials, you know that if there is a sudden change in cross section area, then there will be a stress concentration behavior, right? And because of the stress concentration behavior, we cannot say that the stress distribution will be uniform. Okay, so maybe at one region of the cross section area the stress will be more compared to the other region. Okay, maybe the average will be same, but it will not be uniform. In addition to that, there is a possibility that some shear deformations could be there. Okay, therefore in order to rectify our assumption and make the correction on the true stress calculation, we have to consider what is the stress distribution in this region of the material. Okay, so that's what we're going to discuss under the topic stress distribution of the neck. Okay, and that has been attempted by a person called Bridgman. Okay, he has done a mathematical analysis, and in his mathematical analysis he made some assumptions. Okay, so these are those assumptions he made for that mathematical analysis or stress analysis. Okay, the first assumption is the contour of the neck is approximated by the arc of a circle, which means this curve, okay, this curve is an arc of a circle. That's an assumption he has made. Okay, the second assumption is the cross section of the neck region remains circular throughout the test. So anywhere if we section it, okay, perpendicular to this axis, then what we observe is the cross section region is a circular region. So that's what another assumption he made, and that's a reasonable assumption, because for a cylindrical specimen there is no reason to become unsymmetry, axial unsymmetry, right? And then he assumed the failure criteria, which is von Mises criteria. Okay, if the yielding is going to happen, then the yielding will happen when the stress tensile, because right now it's no more a uniaxial stress behavior. It's going to have a multi-axial stress behavior. For that we require some multi-axial failure criteria, and for that failure criteria he used von Mises criteria. Okay, and finally the assumption he made is the strains are constant over the cross section of the neck. which means for any cross section or any infinitesimal piece we take, and in that one the strain is uniform. That's another assumption he has made. Okay, with all those assumptions he has come up with a corrected sigma, which is this sigma, which is equal to the average sigma divided by this one. Okay, where in this one, this R and A are, this A is the this radius of this this cross section, okay, and R is this radius of this circular arc. Okay, so with that yeah, with these assumptions he made this correction to the stress strain, the true stress true strain curve, and this is valid after the material becomes or starts to get nicking. Okay, and so that the corrected stress strain curve is given in figure 8.4 that we could see. Yeah, so this is the true stress curve, and this is with the correction proposed by Brickman. Okay, right. So that's yeah, so that's something a deviation from the true stress true strain curve, and that has been observed while we consider the stress distribution at the neck. Okay, thank you.